Hello. Okay, I've been off air for a little while. Been off of YouTube. Real work got in the way, Christmas and all that. And I needed to make a couple of decisions about what I was going to do with the emulator. So one of the things I was looking at was wrapping it up in some sort of user interface to actually put more flexibility into the CLI. I looked at GTK. And I looked at NCurses, and I decided to use NCurses because it was actually quite simple to convert the code, the existing code, the CLI code, to NCurses. Now then, the web resource that I used is highlighted there, the tld.org. Very straightforward, follow how-tos and things. And the reason I chose NCurses was it allowed me to continue to use the terminal. You could create zones or windowed areas. We'll come on to that in a little while. And we've got easy text highlighting. You can move the cursor around, very straightforward. And you've got functions for key captures for arrow keys and function keys, and so on. What you've also got is the ability to have non-buffered input, and that might come in useful at some point as well. You can put borders around your windows. You've got windows to keep text contained without, without sort of scrolling outside of that window area. It's all contained within NCurses. But obviously there are different functions, so your normal printfs and your normal input functions don't work within those windows, so you have to use different NCurses functions, and I'll highlight those in a while. And it turned out to be very straightforward, just a few hours worth of work really to put this all together. So the NCurses design, the way I looked at it was I wanted to create something representative here. It's not fully representative, of course, but I wanted to create a kind of an LCD area, a pretend LCD screen, somewhere we can actually put text to get the 6502 code doing something other than on a breadboard, and virtual breadboard as it happens, but anyway. And then the next obvious thing really was to have an area where you could actually see the registers and the flags at all times rather than having to keep display them. So that's quite useful. And the other thing that I noticed was when you put a border around an area, it's on a window rather, it's very easy to overwrite that border because the border itself is just text. So what I came up with was actually using a window within a window, so overlaying a window, if you like, so that the actual the LED window there, it doesn't have a border, but the window that it's actually sat on top of does. So it looks, for all intents and purposes, like you've got a border. But in reality, that window is just a blank window, so you don't end up overwriting things. And then you've got the user space window, which is where you put your input. The other thing to note about NCurses is that it uses this function, this screen called the standard screen, and that's what you get when you start up NCurses. But we don't really use that. That's where printf and stuff would actually start printing to, but we need to use different functions to print to these windows. Okay, so the process of running up NCurses is quite simple. First of all, you install it, and on Ubuntu you would use the sudo apt-get install command. Step 2 is to initialize NCurses within the C program, so you need to include the header file. You need to run the init screen, which is the function to actually initialize NCurses. The cbreak function, that's the one that I was saying before, that allows you to use unbuffered input. So every time you press a key, it instantly returns to the user, and it can be useful, that we could find that useful at some point, especially if we were doing things like customizing the step program, or we could put breakpoints into our program with a Go program, and we could use different keys to slow it down or stop it, or whatever. I haven't implemented any of that yet, but it just seemed to me to be quite a useful thing to have right from day one, so I put that in. The keypad for the standard screen is true. That means that you're going to be accepting all the fancy key, the F1s and the arrow keys and stuff. You can take those in. And the refresh command there, that says, right, okay, so we've now built it, show it. So that refresh command just says show it, and what it does, NCurses clears the screen by default, so you end up with a blank screen at that point. Then step 3 is to create the sub windows. And this is pretty easy. So the stuff in yellow there, that is saying that all these pointers are pointers to an NCurses type of window. Pretty easy. And because C itself is not object orientated, the way to build those windows is to use things like I've created, as you can see, I've created an LCD border win and LCD win as pointers to that type. So you assign them to the result of the function call. So this function call here, which says new win, that you get height, width, start Y and start X. Now note that Y and X are not in orders that most people would expect them to be in. They are back to front, so height is a Y, width is an X, start Y and start X. So that is how high you want your window, how wide you want it in characters, that is. Whereabouts on the screen you want it to start in relation to this init screen here. So 0, 0 will be up here at the top left, and some 100.20 will be sort of kind of here and down here somewhere. And then you do the same thing, here we sort of say then we got to say scroll OK, and that allows that window, that type of window, to be a scrollable window, so text moves around on its own. Similar as in normal terminal, when you press return on the last line and there's nothing where to go, the text moves up. The register window, that's where we were talking about putting the registers. It's same function call again for the main window, same function call. We want the main window to be scrollable, but we don't care about the register window. It doesn't need to be scrollable. And this command here, box, well, that says put a border around that window, and the 00 just says use the standard border type. And same thing with the LCD. Now we're not bordering the main window. The main window is not got a border, as you notice there. And once you've done that, step 4 is to actually display all of that. So that lot creates all the structures and gets you ready to go. And this lot refreshes it. So whatever's in there then gets refreshed. So you use the W refresh, and then you put in the window that you want to refresh. Notice the refresh here, that doesn't have an argument going into it, because the init screen and refresh go together. But if you want to refresh out one of the actual child windows and the sub windows, you need to use the W refresh command there. Okay, and this is the text that we actually used in the code. So we needed to put something in it inside of those windows, else all that'll happen is you'll end up with 3 blank windows on the screen. The MVW print W, that says move within the window and print to the window. So you give it the window you're printing to, you give it whereabouts you want the cursor, and the text that you want it to print. Okay. And the same thing happens here. We end up, we want to play the status register. We're just printing out the details, and you can see it in the bottom right here what it would actually sort of end up printing out. This is the routine inside of our what used to be the display register, or it still is the display register or print register or whatever it was called, function. But now that doesn't exist inside of the command line. This is just a repetitive call so that it actually prints it out in this top right window here. And notice that the MVW print W can also be used in exactly the same way as you would use printf, in the fact that you put in the %2x, which is sort of saying I want to print whatever value that is as hexadecimal, but 2 bytes, but just a two character hex, 2 characters. And again, these are what you're printing out. And this is a customization of the print binary function that I did, or that I borrowed, actually, to be fair. This was written by somebody else, and I've customized it a little bit, but in turn it's the same thing. Now notice I'm not using the MV print W here. I'm just using the W print W, and that doesn't take a position. So what happens with that, that's a little bit like printf. If you print something there, then the next thing it does is it prints at the next cursor location, wherever the cursor was left at. So that's used to print out the binary value there. And as you can see, that's exactly, it's exactly the same principle as it was doing without using the window, apart from we had to change the function call. And again, once we finish doing all of this, we have to refresh that particular window, otherwise you wouldn't actually see what we just made the changes to. And I've called that active text. Okay, and this is the user input function. We had to change this. I had to change this ever so slightly, because I was getting segmentation errors when I was doing it just using this wgetString function. Because if you press return on the wgetString function, it doesn't look, at the moment I'm not happy with this function anyway, with the way I've got this set up, but I've got it working. It'll do for the minute. So the input buffer I set to a null character, and I just say while it's still null, keep going. So this wget thing, if you press return on there, you get a null character back because we haven't put anything in. So it just chucks it back round and waits for you to put a character in. If you didn't do that, it would actually try to string tokenize a null character, and it can't do it. So it's not clever enough to realize that. And the other thing I don't like about it at the moment, and I can't work out if there's a better way of doing this, I'll have a look, is there's no maximum on that. So for example, with the original function, you could tell it how big the buffer was and it wouldn't allow you to buffer overflow. I've not tried it with this, but it looks like you probably can buffer overflow. Okay, so this is what it looks like on the actual screen. And we've got I've written a couple of little routines. I've customized some of it. This is now version 7 of the code. And if we do help, for example, and we keep pressing return, you will notice that the contents scroll underneath those two top windows, which is great because that means that the windows are obviously independent. If we do help again, you'll notice that the R command, the register command, has gone because the registers are now up in this top window here. And also I've changed the disassemble command because it occurred to me that allowing somebody to be able to disassemble a single line was actually quite a useful function to have, so I customized that. And the other thing is the screen function works of a fashion. It doesn't actually work incredibly well, but it does work of a fashion. So if we look here, and we can see that FF04 is where the program counter is pointing to. So if we go back into the code and we look at FF04, well there's FF04, and FF04, first thing it does is it jumps to screen print. So screen print is up here, so it jumps to FF10. FF10 is here, and that does an LDX immediate of a value of 0. So it puts 0 in the X register. The LDA absolute, so it takes the value that's in FE00, so it becomes FE00, X, so and for the first pass round it's FE00, and FE00 is up here, and FE00 is the character representation of that. So after you've spun around that routine several times, it will have printed out that entire string. So what it does is it now sets the A register to the screen memory. So it stores the absolute value to the screen memory, X, so whatever is in A, and A is carrying, the first time around it carries that asterisk, and the second, and then it says increment X, and then it compares X to the value of 10. It says, have we got 10 characters? Not the first time around we haven't, so it goes back and does it again, but obviously X is now 1, so it lowers it to 6, and the second time around X is 2, so it lowers the 5, and so on and so forth until it hits that RTS. The RTS then jumps back to where it came from, and then it RTSs out, which is the stop for our go command, if you remember. Now if I say go on this, it's not brilliant, but it kind of works, and as you can see there, it prints out 6502 EMU in the screen area. There are issues with this, and I'm not actually overly happy with the way that's written at the moment, but it was just a quick bodge to see whether or not the NCurses stuff was working the way I expected it to. I've added an IO function there, and this is basically the screen handler. It's not brilliant. I'm going to do it differently than this, but this was just a quick sort of test. So all it does is it goes round in a loop. So 4096 is hex 1000. It takes the size of the screen memory, and that's just a defined value in the FSM header file up here. So we can sub here somewhere. There it is. So screen mem there is set up as height times width, and we know that the height is 8 and the width is 20, so 20 times 8 is 160. But rather than do the calculations and things, if I wanted to change the screen sizes, I just do it there, right? And the maths throughout the rest of the functions, they just work. So this IO function then goes round and round and round, and it uses this wprintw, because if you remember the wprintw, first of all it moves it to the initial starting position of top left there. That moves the cursor within that window to the top left, and then it just works its way down from there, or across and down if you like. And then obviously we run the refresh on the window, and that's called from inside of the execute command here. So the execute command now just calls the screen handler, and so does the step command. Now it's not working the way I expected it to at the moment, but I will try and fathom that out, and I'll show you what the actual problem is. If we reset the machine, and if we do an X and reset it, we'll notice that the whole thing resets. Gets rid of whatever was in the main screen there, puts the program counter back, clears all these registers, clears all the flags. Now if we step, what should happen to my mind at the moment is it should start drawing the various sort of components on the screen at some point. I mean, because if you look there now, it's gone through that iteration going back through the FF15, FF12, and if we do a memory dump on hex 1000 to say hex 1000A, we'll notice that actually it's done quite a few of them, because the original values in hex 1000 it was filled with 20s. I did that on purpose, but if you look here, it's got 2A, 36, 35, 30, and you can see on the right hand side there, because we did this on our memory dump, it started to build that string in memory by copying it out. But each time around the step, it's actually doing the screen handler, and the screen handler is obviously not optimal, but it's drawing this entire screen, or supposed to be drawing this entire screen, okay, but it's not doing it. So I need to do a little bit of debugging on this, but if we continue to go with this, as we can see, the more we go, and you can see that the code is obviously spinning round. So if we do that that memory debug again, we'll notice that it's actually got most of it already in there. So if we keep stepping through this, at some point it'll get to the end of this. 1B, 1.2, it's still going there. 1.8, 1.9, 1B, 1.2, so it's still copying. 1.9, 1B, 1.2, and it's still copying. And I don't understand what it's doing, but if you see, so it's actually printed it out at that point, but I don't know why it took it that long. So I need to do a bit of debugging. Maybe it's I'm pretty certain it's a screen handling routine and not the main code, because when I did this the old-fashioned way and printed it to a file, it printed it to a file character at a time. And if we customize this and we actually get it to print something to the main window at that point, like say tell you you're in that routine, that works as well. So it's just something odd, and I will get to the bottom of why that's doing that. Okay, so that's the end of this short video, just as an introduction to where I'm up to at the moment with the cursor stuff. I'm still kind of learning my way through what it does, how it works, but I'm kind of pretty pleased with the results I've got it to at this moment in time. Everything was quite easy. Certainly using Genie, it was quite easy to migrate, because you just sort of did a global search for printf and changed it to the relevant function. That didn't take very long at all, and actually sort of understanding the tutorial that came from this website here was very, very simple. It's not a very verbose tutorial. He goes through it very clearly. So if you click on the initial thing there, he sort of goes through how you compile with NCurses, and that's something I forgot to mention, is that the fact that you need to add the library. So I did actually customize the make file to include that. So inside of the inside of this, you can see, oh yeah, I was working with that. But if you actually look here now, so there's the make file that I've been using, and the make file I did a bit of customization on, and I just included the libs directory at the end there, and added the NCurses to the end of that. So if we do a make on that, there we go, it makes fine. So yeah, this is the root source of all my my current knowledge on NCurses. So a great thanks to the person who wrote that. And we'll see where we move on to for the next video.